What's the flow time of C? 9. That's right. Okay, so this one is the one we looked at yesterday. So I just wanted to show you that the diagram that the textbook brought up, because we had what we had, and I'll just show you. So for this part up here, we had it. So I had A coming out, and then I had B coming out, and we had, I think we had C. Sorry, so that was A and B, and we had C, and we had D coming out like that. And what we did is we put a double dummy in between those two. It's the same thing. It is okay, but the only thing was when we were backtracking, which means we were doing the red number, we had to take into account this number down here for that. And so that way you had to be really careful. So I thought that I'd show you this one. This is how the textbook did it. Now, it's not to say we're not right. Like, we were still, you know, you could draw it, as I said, there's lots of different ways of drawing it. It's okay. But just to show you with the backtracking how, where I'll show you where it comes into a bit better if it was drawn like this. All right, so let's start. I'm going to quickly go through this one. So remember, this is the earliest starting time. So that one would be 0 and 0. And if we flew along the top and we wanted to say the earliest starting time, we could say was 6, or because if we go the B way, it's actually, because B's connected, it would be 9. So that's where we do it. And the same with D, 9 will be the starting thing. Okay, so if we go along, keep going along, if we go F, so 9 plus 8 would be 17. But if I went along this way, so say to get to E, it'd be 9 plus 7, which is 16. But 16 plus 10 would be 26. So this one now becomes 26 because we've got to do the biggest one. Then we add 12, and we get 38. Okay, so the earliest finishing time for this project is 38. And then we work backwards and we get 26. Now, if we do 26 minus 10, we get 16 along this way. If I do, and then 16 minus 7 would be 9. So there's the 9 if I went the D way. If I went via the C, it'd be 26 minus the 8, which is, what's that? 18. Okay, so remember when we're backtracking, we take the earliest one. So 9 minus 6 would be 3 there, or 9 minus 9 would be 0. So it's this point where we might not have seen that. Our 9 was down here, and we had 9 and 18 up here, and we might have been tempted to do the 18 up there when we backtracked. So it's actually here, it's only, and it would have affected this number here, but we've done that. So just to refresh, the critical path is the one that has the numbers the same. So you can see that. So this one would have been, we've gone along D, and then obviously we go along B. Okay, we would go back to B. All right. So this is just going to summary up, and then I'm going to stop it there, I think. So if we look at the critical path is a sequence of edges that makes up the longest path. So the longest time is the critical path. The process of terming the critical path is critical path analysis, which we call the flowing. So we go through on the blue and backtrack on the red. So a project has 8 activities as shown in the precedence table opposite. Draw an activity network for this one. All right, so let's start with our activity network first. So we've got the start, and you can see A has no predecessors, and either does B. So I've got B, and because it's giving the durations, so I better start putting the numbers on there as well. And then we've got C. I'm just going to put C out here. Also has no predecessor. So D is a predecessor to D. So I might do that. And then E is also a predecessor, so I might put E up here. Sorry, so D was 4 and E is a duration of 7. Okay, so I'm down to that. Now I'm up to F, which is B and D. So I might draw into here, those ones. And then I've got F, which is 5. Okay, I've done that one. And then we've got G has E and F. So I'm bringing these two in together because they lead on to G, which is 6. Okay, and then H came from C, so here, and there's nothing after those two, so that's the end. So this was H, and it was 2, and then we've got the end. All right, so we've drawn the activity. Now it says complete the critical path analysis. So let's draw all of our boxes. So I'll just draw it in blue. So don't forget B in there. And then we've got C. Okay, so they all are 0 to start with. Then we have, I'm just going to draw the 2 here. So we've got E and we've got D. Now, they would have to wait for A to happen. So that's 3 and 3. Then you've got F. Now, F leads from B, so if I came just straight from B, it would be 5. But if I come from the A and the D way, that would be 3 plus 4, which is 7. So I'm going to pop in 7 there. Okay, just going down here, I'm going to do the H. So H would start at 12 after C. And then, what else have I not done? G. So G is it comes before F or E. So if E would be 3 plus 7 is 10, or if I came the F way, it'd be 7 plus 5, which is 12. So 12 is going in there because you've got to pick the longest. And then we get to the end. Now, if I went, now the end of the G way would be 12 plus 6, so that would be 18. But I'm just going to check here. I'd have H, if I went the H way, it'd be 12 plus 2, which is 14. So 18 is the bigger number, and I'm putting that in. Now I'm going to backtrack. So remember, so 18, maybe if you write, it might ask us that. Oh, we'll do the questions later. So 18 is the earliest completion time, yeah? Okay, so then we're going to go back. So 18, if I go minus the G way, so 18 minus 6 is 12. That's okay. Now, if I go back along the F, 12 minus 5, that would be 7. If I went back along the E way, it would be 12 minus 7, which is what? 5. Now, if I kept following along that D path, 7 minus 4 is 3. So there's how I got those two. And if I keep going backwards, you've got to pick the smallest. So it would be the D version there. So 3 minus 3 is 0. If I'm back at the start of F and I want to go backwards via the B, that's going to be 5. So I'm going to see a 2 in there. And then if I went backwards from the end the H way, so 18 minus 2 is 16. And then 16 minus 12 is 4. So you can see, I'll show you the critical path in green. So the critical path would be, you're at the end, we're going to go along the G, we're going along the numbers that are the same. So F, D, and A, that's the critical path. So the ones that have float times are the ones that are different. So E has a float time, H has a float time, B, and C. Okay, so then we should be able to answer the questions. Okay, so we've drawn the activity, we've done complete the critical analysis to calculate the earliest and latest starting time for each activity. We've done that. So I'm just answering the questions over here. It says C, what is the earliest starting time for H? So remember, that's the blue. So this was talking about weeks, so we'd say 12 weeks. How do I know it's weeks? Up in the table, they said duration, they're talking about weeks, yeah? If we look at D, it says what is the latest starting time for H? So that's the red number. So what's that one? 16 weeks, good. Then we look at question ABC. What are we up to? E. What is the float time for H? So remember, the float time equals the latest starting time minus earliest starting time. So 16 minus 12. So 4 weeks is the float time for there. And, sorry, running out of room, so I'll go up the top here. F, question F. Write down the critical path. So I've already done it in green. So I'm going to say start, then we went to A, we went to D, we went to F, we went to G, and we went to the end. So there's our critical path. What is the minimum time to complete this project? So that's what I say when we get to the end. So what was this one? 18 what? 18 weeks. They'll probably test you a lot on that unit, so make sure you're reading the table, like have a look at what you're actually talking about. And H, the person responsible for completing the activity E falls sick 3 weeks into the project. If he will be away from work for 2 weeks, will this cause the entire project to be delayed? So, no. Why? Yeah, he's got a float time of 2. So, good. So, I'm going to say, yeah, will the project be delayed? I'm just going to say no, because there is a float time of 2 weeks for activity E, yeah? All right, let's have a look. A project has 12 activities. The network below gives the time in hours it takes to complete each. The critical path for this project is, so you know, the only way, you might as well don't pause about it. You've read in reading time. You know you're going to have to do all those earliest starting time things. So then you just go straight into it, because then it makes it easier and you can see all you're working out. So I'm going to put A. I like to put B there, and then I've got C. Okay, so they're all at the start, so they're all a 0. And then if I move up here to D, D has to have A start, so that's 5. Okay, and if I go, I'm going to go down here to F and E. Now I've got 2 there, so I probably should have 2, so I'm going to write E and F. So they both needed for C to happen, so that's a 4. Okay, now when I get to G, G has to wait for D, B, and E to happen. So let's go along that way. If I came from E, it would be 4 plus 8, which would be 12. I'm just going to write them up roughly at the top. If I came from B, it would have been 10. If I came from D, it would have been 5 plus 6, which is 11. So which one am I going to put in? 12. So we put 12 in, and you might just rub them out, okay? Going along here for H, so H needs to think about B or E. So if I came from B, it would be 10. If I came from E, it would have been 12. So that's how that one gets a 12 in there. Okay, what about J? Now, J has to wait for F or H. So H would be 12 plus 10, which is 22, or 4, so plus 10. So this one is definitely the 22 is the bigger number. Okay. Now, L I can see has J and I coming in. If I came in the J way, it would be 28. If I come through the I way, well, I need to do a little bit more here. So I'm going to have K, and I need I as well. So I is coming from G, so 12 plus 9 is 21. And then K will also be 21. So 21 plus 9 for the I would be 30. So that's bigger than the 28, isn't it? So I've got to put 30 in there because it was 30 from the coming from the I way. Okay, and then we get to the end. The end, I've got two options. I could come from L, which is 35, or I could come from the K, which would be 34. So which one am I going to put in? 35. Okay, so now I've got that. Now I'm backtracking and I'm looking at, so 35, and now I've got to look, I'm looking for the red. So 35, if I go the L way, 35 minus 5 will be 30. Okay, if I go the K way, what's 35 minus 13?
22.
22. Okay, if I go from L back the I way, what's 30 minus 9? So there's 21 in there. And then if I go from, I'm going from the start of K and I, and then I'm going to go back to G. Now, so I have to pick 21 because 21's the smallest at that point. So 21 minus 9 is what? 12. So if you just might, because you might be getting a little bit lost there, just write that was the 21 minus 9. That was the I way, yeah? Okay, and now we're back at G. Now I could go, if I go via the D, 12 minus 6 is 6 up that way. If I go, if we're sitting at H, wait a minute, H is, well, if I'm going to go back to J. Down the bottom, 30 minus 6 would be 24. But because of this dummy here, H is also sitting at 12 because that's connected to that. Okay? So you see this dummy? So if G is 12, so is H. Yeah? Okay? All right, that's a bit, this is a trappy question, yes? So now we're going to go 12 minus 8 is 4 if I went the E way. If I'm down here on the bottom, 24 minus 10 is 14. That's that way.
Shouldn't be 22 is the lowest.
No, we're still looking at red numbers, red numbers. So, and then here I have to use 4 because 4 is the smallest. So 4 minus 4 going C would be back to 0. If I went along the B, I'd have to be at 12 minus 10, which is 2. So there's that float time. And if I went along the A, it'd be 6 minus 5, which is 1. So now we can see the critical path. So just doing it in green because I have been. So I'm looking for all those numbers. Just highlight them first that are the same. Okay, so then I know. So I went to L, to I, to G. Then we were down here at this point. Okay, and then I went E and C. So which answer is that? So what it actually is L, I, G, E, and C. And oh, but I'm saying it backwards, sorry. So which way wouldn't it be? D. Okay, question 4. A community centre is to be built on a new housing estate. 9 activities have been identified for the building project. The directed network shows the activities and their completion times in weeks. Determine the minimum time in weeks to complete the project. So that's the critical path. So you know what? You're in a short answer exam. You're going to have a few questions. We're going to not hesitate and we're just going to do our flow chart, or our backtracking and all that. So 0, 0 up here, D, so it'd be 4 when I'm at, now this one is, I'll put the 2 there, so we've got the C option or the E option, and both of them need B to happen first, so that's 4 and 4. Down here, F would be 4 plus 3, so 7. And we've got to be careful with this H because it can come two ways. So 7 plus 4 is 11, or if I came via E, it'd be 4 plus 4, which would be 8. So I'm going to pick 11. Up here, I'm just adding, for G, I'm just adding on 1, which would make it 5. Then I get to I, and I've got to be careful. If I came the G way, it would be 8. If I came the H way, it would be 13. So I'll put 13. And then I add the 6, the last activity. So we end on 19. So there's our 19. So I've got to the end. So when it says determine the minimum time to complete, what's the answer for that? 19 weeks. Okay. And then it says determine the slack time. What do you think slack time means? Float time. Good. For D. So let's quickly go backwards. So 19 minus 6 is 13. I'm heading towards the D, sorry. So 13 minus 3 is 10. And then 10 minus 1 is 9. So what is the float time? Yeah, so I'll just write the earlier start time. So it was 9 minus 5, which is, 9 minus 4, which equals 5. And this was weeks, okay? So they were talking about weeks. 5 weeks was the slack time. Okay, question 2. 13 activities must be completed before the produce grown on the farm can be harvested. The directed network below shows these activities and their completion times in a day. Determine the earliest starting time in days for activity E. Okay, so we obviously are going to do forward and backward tracking, and hopefully you can see E is here. So, but to do the earliest starting time, well, that's just forward tracking. So we could just start at the start. So we've got A is 0, and then we can do our other ones. B would be 10, but I'm heading down towards E, so I'll go down this way. So D would start at 2, and then I'd have 10 plus for the E would be 12. So I can say the earliest starting time is 12. A dummy activity starts at the end of activity B. So we can see the dummy, yep. And explain why this dummy activity is used on the network in the diagram. So obviously B needs to be completed before G and H can happen, as well as F. Okay, so we needed the dummy in there. So just to write that out, so you've got an answer, I'll pop it in. Okay, so activity F has only B as a predecessor, while activities G and H have both B and C as a predecessor. So you cannot have two activities called B, so you can't have those parallel edges. So our dummy activity is drawn to form an extension of B to the start of G and H, because G and H also have B as a predecessor. Okay, so with this, continuing with this question, it said this earliest starting time for H as well. So hopefully, and then if you look at the next question, it's a critical path and determine the latest starting time for J. So hopefully in reading time, you'd read all this and you knew that you would have had to complete the whole forward tracking and back tracking. So when we were back at part A, we probably should have kept going. So we'll keep going with the forward tracking, finishing off. So C had a earliest start time of 10, and then we have F up here, so that continues on to be 15. Now just remember, if we have G coming down and H obviously as well, so at the moment 15 is coming in from there. If I look from the C, it'd be 10 plus 3, which is 13, so that's not bigger than 15, and so I'm going to pop in 15 for G and H as well. And then if I keep going, here, if I look at I, so 12 plus the 5 from E would be 17, but the 15 plus the 4 from H is 19. So that one became 19. Then I move along with adding I would be 22. Now I get up to another junction for M. So if I was coming in the L way, I'd be sitting at 26, but I just better check the other ways. If I came in from G, it'd be 15 plus 6, which is 21. And if I came in from, just going to put K here, so K would be the 15 plus the 9, so got 24. And then if I came into M from K, it would be 25. So 26 is the biggest. So sometimes I'm just going to rub out those ones. Okay, and then we get down to the end. 26 plus 2 is going to be 28. But if I go the J way, so remember this is 24, this is for J. 24 plus 3 would be 27. So I'm going to leave it with 28 being our biggest. Then I'll just rub out those two. Now I'm going to go backtracking in red. So 28 minus the 2 is 26. 26 minus the 4 is 22. Or if I go from this M, this 26 minus 6 along the G way would be 20. Now if I go down on bottom, so 22 minus 3 is 19, and then 19 minus 4 is 15, so up here at H I get the 15 and the 15. Now remember this dummy here, so the lowest number sitting up here, I could go via, go backwards from F, so 24 minus 9 is, would be 15. So that is 15, or coming down from here is 15. So F is 15 via two ways there. Okay, and then we've got minus the B, so 15 minus 15 is 10. And then if I go along the C, I've got 15 minus 3, which would be 12. Or I'm going to finish down the bottom, going back via E, so 19 minus 5 is 14, and 14 minus 2 is 12, and then right back to the start. So the next question here is determine the earliest starting time for H. So we would have all done that, and we can see that, and we can write 15 days, I think it was. Or you can just write 15 in order list the activities on the critical path. So remember they're the numbers that are the same. So I went from M down to L, across to I, and then up to H, and then along the dummy. So then I went along B, and then along A. So now I can write out in order. So A to B to actually H, because via the dummy, and then I, L, and M, and determine the latest starting time for J. So that's the red number at J. So I've obviously, whoops, haven't completed that up here. So 28 minus 3 would be 25. So for J, it would be 25. If I was going the K way, I'd have to come back this way. So it would be this 26 minus 1, which would make that one K 25 underneath. So it didn't really matter, but they were both 25. So the latest starting time was 25 days for J. Okay, so here roadworks planned by the local council require 13 activities to be completed. The network shows the 13 activities. So this is where it's crucial we need to use our reading time, particularly for this networks. So it says what's the earliest time for
K, so we could do forward tracking. But this question B says how many activities have a zero float time. So then we need to do the whole critical analysis for the whole network. So when you get here, we're going to go straight into it and draw it up. So we've got activity A, and we have activity B, and I've got a starting time of 0. They're both at the start. And then I get to here, I might call this one D. So we're moving into D, it's come along A. So at the moment, I'm just going to say coming along A is 6, because we've got to remember we could come this way. So 3 plus 2, if I came via this C, it would be 5. So 6 is the biggest. So, and then I'll just, just rub out those little numbers, what I was waiting for. Now, I've also got E coming out here. So E also will be 6, because that's at the same spot. Okay, so following along up here, the 6 plus the 3, that one makes the 9. And here I've got L. Now, if I was going along the G way, I would have 9 plus 4, which is 13. I'm just going to leave that there because I can see there's another entryway into it. So if I have H here, H would be the 6 plus the 5, which is 11, and 11 plus 2 is also 13. Okay, so I'm happy to leave the 13 there. All right, so then I might keep continuing along the bottom. So the C3 plus 5, well, this is going to be for K. Now I'm just going to put 8 there because I can see J comes along here. So from H going like that, plus so I could put J here, it would also be 11. So 11 plus the 3 would be 14. So this one's actually going to be 14 there. And so I'll rub that out. We get to the finish via K. So that I'm just going to write 17 coming this way, but I've got another way to get to the finish. So if I come along here using I, 11 plus 2 would be 13, or I've got 13 plus this L5, which is 18. So I'm putting 18 in there, and 18 plus 1 equals 19, so that's bigger than that 17. So we'll rub that out. Now we can backtrack via our way. So 19 minus 1, 18. If I go this way, 18 minus 5, I get 13. Going backwards via H, 13 minus 2 is 11. If I go back to the finish and I go along K, 19 minus 3 is 16. And then via J, 16 minus 3 is 13. Okay, so remember you pick the smallest, which would be 11. So 11 minus the 5 will be 6. So this one will also be 6. And then we've got 30 up the top here, this 13 at L minus G is 14, which would be 9. Then 9 minus 3 is 6. So we both, via the D is 6. I accidentally put that one in. Then 6 minus is 0. If I go via C, 6 minus 2 is 4. If I went backwards via F, it would be 16 minus 5, which we probably should have had, another one here for F. And so F would have been 3 as well, but fine, here's 11. But we'll take the 4, and then 4 minus 3 is 1. Alright, so there's the full backtracking. So first of all, what's the earliest start time for activity K? That was there, so 14. What were these? In weeks, so 14 weeks. You can just write 14 because it said in weeks, so that you just write the number, I would suggest, so we don't accidentally write the wrong one. And then how many of these have a 0 float time? So the critical path will have a 0 time float time, but you just count the numbers that are all the same. So we've got 1, 2, 3, 4, 5, 6, 7, and so yeah, it's actually 7 activities. Be careful because I'm actually circling the float times, but if you look, if you draw the activities, so like here, you know, it was activity D, activity A, so 1, 2, G, and L, and H, and M, and you don't really count the finish. So you've got 1, 2, 3, 4, 5, and also E, 6, and 7. So there should be 7 activities.